All right, analysis of variance and multivariate analysis of variance. So analysis of variance, usually ANOVA, multivariate analysis of variance, or MANOVA. ANOVA is a statistical test used to test whether the difference in means between multiple groups is statistically significant. So difference here between a t-test, really identical, except with a t-test you've got only two groups. It could be a pre and post, could be two different groups. You're looking by a binary gender, or however you want to split your data into two groups. For analysis of variance, you're looking at testing the difference in means between multiple groups, so greater than two. You actually technically can use ANOVA for just two. T-test you could only ever use for two. And then a MANOVA, or a multivariate ANOVA, is just what it sounds like. You're using to determine whether multiple levels of independent variables on their own or in combination, looking at the potential for confounding, you can measure that, with one another have an effect on the dependent variables. This is again a parametric test, which means we're assuming a normal distribution of continuous data. So that bell curve, Gaussian curve, normal distribution, and that the groups have equal variance. So a little bit more than you need to know, but standard deviation variance similar between, not identical, but between your multiple groups. All right, let's take a look at what that looks like if you're seeing this in a paper that you want to interpret, so peer-reviewed published paper. And you've seen this table before in a couple other modules where we looked at t-tests and linear regression. This also, for this same study, includes an f-test, which is the test statistic associated with analysis of variance or multiple analysis of variance, ANOVA or MANOVA. And again, you see that we have just the p-values, not the test statistic. This is uncommon anymore that journals don't want both, the magnitude, the size of the test statistic, as well as the p-value. Same variables in how we've looked at this table before, so we're looking at predictors of the percent of BSA, or body surface area, that's protected from the sun during beach or pool observations. The coefficients and the point estimates and 95% confidence limits are from a linear regression. T-test, the f-test, then allows us to look at all of them. So you see for the t-test we have two different p-values, and for the linear regression two different coefficients, because you can only look at two at a time. So you're comparing one to the reference. The f-test, from the analysis of variance, lets you look at all of them together to see whether or not that is statistically significant. And so you see that f-test for analysis of variance.